and I am going through some of Activity 5 in the SpringBoard book. So I'm going to start with some examples from Lesson 5.1, Relations and Functions, and I'm on page 67. So I just wanted to go over some different representations that we can use for functions. So relations, which it had said on the previous page, is a set of ordered pairs, have a variety of representations. Consider the relation 1, 4, 2, 3, 6, 5 shown here as a set of ordered pairs. This relation can also be represented in these ways. So we have a table. We always have our x values on the left column, our y values on the right column. They should line up with our ordered pairs, so they give us 1, 4, 2, 3, 6, 5. If we have a mapping diagram, we would put our x values on the left oval, y values in the right oval, and then we also usually put them numerically. So I kind of don't like how the book did this, because the left side is in numerical order 1, 2, 6, but then we would also want to put the right side in numerical order, so we would do 3, 4, 5, and then we would have 1 pointing to the 4 for the output, 2 pointing to the 3, and 6 pointing to the 5. I think they just did that to introduce it, but I want to show you the correct way would be this. So you want it in numerical order always. And then over here the graph has these ordered pairs as well. So we have 1, 4, 2, 3, and 6, 5 up here. And then if we are given numerical mappings as ordered pairs, just to practice writing them. So if we're given the input of 1, output -2, we would write 1, -2 in parentheses. Make sure you always put ordered pairs in parentheses. 2, 1, parentheses 2, comma 1. Then we have input 3, output 4, parentheses 3, comma 4, and input 4, output 7, 4, comma 7. Go ahead and try the check your understanding on your own right now, just to see what you are understanding. And after you do it on your own, come back to this video and I'm going to go over it just to check to see what you got right and what you need to maybe work on more. So go ahead and pause it right now and do number 6, A, B, and C. All right, welcome back. A vending machine at the Ocean Road and Air Show creates souvenir coins. You select a letter and a number, and the machine creates a souvenir coin with the particular vehicle imprinted on it. The graph shows the vending machine letter number combinations for the different coins. So we have a boat, train, car, bus, and airplane. A, make a So remember, our table only needs the x and the y axis. So we could include like what picture is on the coins, but for this case, I'm just going to keep it simple and just do the letter number combination. So I'm going to use this note section over here. So this is A. So input, and y is your output. So in this real world situation, I'm inputting a coin, and the output would be a vehicle imprinted on it. So for this, my output would be 5, so A, 5. Then I have B2, B, C1, and E3. Then for B, write the letter number combinations as a set of ordered pairs. So going back from my table, I had A5, so I put parentheses B2, C4, D1, and combinations in a mapping diagram. So this is where you would want to make sure they're in numerical or alphabetical C, D, E. And then over here, I would put it also in numerical order. 1, 2, 3, 4, 5. So A was 5, so I'd come down here. Sometimes it gets a little messy. B, 2, C, 4, D, 1, and E, 3. And then I'm going to jump over to number 11. So determine whether the ordered pairs through 68 really quick. A function is a relation in which each input is paired with exactly one output. Have an ordered pair, the input is your x value, the first number, the output is your y value, the second number. So in this case, the input 5 can only have an output of 4. Input of 6 can only have an output of 3, and input 7 can only have an output of 2. So yes, this is a function. Each has exactly one output. Go ahead and pause the video and write what you think. So for this one, notice how my input of 4 has an output of 5, and then my input of 4 also has an output of 3. So that shows that my input 4 has 2 outputs. So no, this would not be a function. Two outputs. Letter C, 5, 4, 6, 4, and 7, 4. Pause the video and try that one. Students get stumped because they're like, well, 4 is repeating, we can't have a repeating number. But that's not true because 4 is the output. Notice how all of the inputs are exactly one output of 4, 6 has exactly one output of 4, and 7 has exactly one output of 4. So yes, it's okay if the y values or outputs repeat as long as the x values don't repeat. Then we get into equations. Y equals 3x minus 5, where x represents input value. Input any number for x, and then let's see what we get. So let's say we did x equals 2. So I'll do y equals 3. Solve it, multiplication first. 3 times 2 is 6. 6 minus 5 equals 1. So my input was 2. Answer I will get for substituting 2. So that input has its own output. Let's say I plugged in x equals 3. Y equals 3 times 3 minus 5. 3 times 3 is 9. 9 minus 5 equals 4. 3 associated with it. So yes, this is a function because each input will have exactly one output. And then we're given another equation down here, y equals negative x plus 4. Same thing, x represents input values, y represents only get one answer. So yes, each input will have Go ahead and try number 12. Using positive integers, write two relations as lists of ordered pairs below. One that is a function, one that is not a function. Is the map function explained? So go ahead and do this, pause the video, and then come back and check your answers. All right, so looking at 2 has only one output of 6, 3 has only one output of 7, 5 has only one output of 9, 4 has only one output of so 1 from each input, that is, yes, a function. Each input points to only one output. And it's okay, again, if we see them pointing, like 3 values in this first oval only have one arrow pointing from each number, you're good. It's a function. 14, does the graph shown represent a function? So again, we have an input of 2 here. 2 has 2 different outputs. Input 2. One output. So no, not a function. Also, some students have heard of the vertical line test, and if you have not, or you need a reminder, if I were to take like my pencil and put it in a vertical position like this, up and down, across my graph, if it touches more than one point at a time, then it's not a function. So going over this input of 2, I would vertical line test as well. All right, then I'm going to move over to lesson 5.2, domain and range. So important definitions, remember to highlight the set of all inputs for a function is known as the domain of the function. The set of all inputs of a function is, as the set of all outputs. Range, and I'm on page 71 right now, lesson 5.2. So this one gives us another vending machine. We're inserting 25 and including all 10 pencils. So 25 cents gives us 1 pencil. 50 cents. Identify the domain of the situation. So the way we write domain notation, and something else over here. For example, for the function 1, 2, 3, 4, 5, 6, the domain is, and we put these brackets around it, 1, 3, 5. So these are all the x values from our relation. And the range is brackets 2, 4, 6, which is all of the y values that were just given in these ordered pairs. This is for domain. Then you put these brackets. They're not parentheses, so make sure you're using the brackets. Practice. I know they're a little weird at first. Then we're only putting the x values. So think about the vending machine. The input is the quarters, 25 cents at a time. So we would start with cents, $1, and it goes all the way to 10 pencils. So I can think 10 times 25 cents would be $2.50. So I'm going to go in increments of 25 cents, $2.50, and then end it with brackets. Identify the range of the Think of your outputs. If I put 25 cents in, I output 1 pencil. I could get 2 pencils, all the way up to 10 pencils. Here are some other functions below with different representations. For each function below, identify the domain and range. So again, we have a table, 7, 6, 3, -2, 5, 1. So my domains would be all these inputs, and again, I want to put them in numerical order, and 7, and then end it with brackets. Range is 6, -2, 1, so -2 would be my smallest number. 1. And then mapping diagram, X values are your domain, so X and Y. So my domain is 2, 6, 8, brackets 2, 6, 8. And then my range is -3 and 4. Going down to the ordered pairs, it helps me to actually write out these ordered 3, 1, and 5, 3. So again, your first number is your X, your second number is your Y, domain is our X, range is our Y. So we have for X 2, 3, 5.
Please be at your duty station.
And at the second number, 1, 3, 4. All right, last one I'll do in this video. We have a relation, which is again, my domain is my first numbers, my X. I have -7, 9, and -6. So to go in numerical order, I would put -7, -6. 2.5, so -3 is the smallest, then 0, and then 2.5. All right, go ahead and try some on the next page to practice on your own. Thank you for watching. Have a great day. Bye.